Hello students, welcome to the channel. Today we look at the basics of scatterplots. Scatterplot questions are frequently tested on SAT Math. So let's begin. A scatterplot is basically a diagram which has a set of dots in it, and these dots are meant to convey the relationship between two variables. So let's say I'm plotting the relationship between x and y, and I mark all the dots where I have data points. Then the curve that I get when I try and connect these dots tells me the relationship between x and y. So here I can see that when I increase x, y also increases. So this is a positive association. Here, when I increase x, y is declining. So this is a negative association. And here in the third one, I'm not able to make out any association because the points are randomly distributed. Now, in the first two cases, what we have is a linear association between the variables, and the line that is used to indicate that linear relationship is called the line of best fit. So let's look at a sample question that you are likely to get from a linear scatterplot. The scatterplot here shows the maximum height h in feet and maximum speed s in miles per hour of 12 roller coasters, as well as the line of best fit for the data of the following, which best represents an equation for the line of best fit. So here, this is more of an algebra question than a scatterplot question, because even though a scatterplot is given, you are ultimately expected to find the equation of the line of best fit. Now, we always start with y is equal to mx plus c, where c is the y-intercept. And if you're not careful, you might think that the y-intercept is here, like 62 something. And then that might lead you to cancel a and b and work on c or d. But that would be a mistake, because this line here, this line is not the y-axis, because the x value for this line is 140. The y-axis is going to be further left when the x value is 0. So in fact, the options to cancel were options C and D, because those options have the y-intercept at 62. And as we can see here, that 62 cannot be the y-intercept. It has to be a value less than 62, because the y-axis is to the left of this line. So then I can say that my y-intercept would be 32, because the two remaining options have a y-intercept of 32. So how do I find the correct equation? I pick a point. Try and pick a point on the grid so that you know the exact coordinates. So for this point, my coordinates are 320 and 100, right? So if I put both these equations, have s is equal to mh plus 32, where m is different, the slope is different. So if I put this value, this coordinate in this equation, then I can get the right value of m. So the speed is 100, height is 320 plus 32. So 100 minus 30, so 68 is 320 m. So m is 68 by 320. And if I plug 68 by 320 on my calculator, 68 divided by 320, I get 0.21. And since the option with 0.21 slope, so this is 0.21, the option with 0.21 slope is option A, that becomes my right answer. Okay, let's move on. Now, scatterplots don't have to be linear. Scatterplots can be quadratic, like the first two scatterplots here. In this scatterplot, as the x increases, the y value first falls and then rises. So it becomes sort of a parabola. And since it's a parabola opening upward, the equation for this parabola will have a leading coefficient that is positive, right? In this parabola, the leading coefficient is negative because the parabola is opening downward. The leading coefficient is when I write the equation of the parabola as ax squared plus bx plus c, then this a is the leading coefficient. When it's positive, the parabola opens upward. When it's negative, the parabola opens downward. Okay, here I have exponential curves. Exponential curves can be written as y is equal to a b to the power x, where a is the y-intercept and b determines the shape of the curve. When the parabola is increasing, which means it's exponential growth, b is greater than 1. B is greater than 1. This shows exponential growth. And when the graph is decreasing, it is falling, exponential decay, then b is between 0 and 1. So for example, this graph could be 2 times 1.27 to the power x, and this could be 8 times 0.73 to the power x. So the base of the exponent determines whether it's exponential growth or exponential decay. So let's do a sample problem. The scatter plot below shows the amount of electric energy generated in millions of megawatt hours by nuclear sources over a 10-year period, which best models the data in the scatter plot. And I can see that I have quadratic expressions. So let me try and make a parabola out of this. Something like this. So I can see that my y-intercept will be about 740 something, right? Plus 740. So that means I can eliminate option A and B because here the y-intercept is negative 740. So it has to be either C or D. I can also see that this parabola is opening downwards. So the leading coefficient has to be negative, which means that it can't be C because in C the leading coefficient is positive. And so option D is my right answer. So here I didn't even have to look at the graph or plot a point and replace it in the equation. You can always do that to verify your answer, but you don't have to, because here just knowing that a quadratic graph will look a certain way, knowing that its leading coefficient will behave a certain way, its y-intercept can be seen in the constant in the graph, those are enough to get the right equation. Okay, scatterplot questions are also tested on the arithmetic part of the test, which is the problem-solving data analysis part. So let's do a couple of sample arithmetic questions. The scatterplot in the XY plane here shows 9 points and a line of best fit. Of the following, which best estimates the amount by which the line underestimates the value of y when x is 50? So when x is 50, the actual value of y, you can see, is 65, right? And the line indicates a value of y, which is this, which is kind of, let's say 47, something like 47. So the line underestimates the actual value of y by 65 minus 47, which is 18. So the right answer is option D. Okay, another one. The scatterplot here shows the number of surveys sent to and returned from people in 17 different neighborhoods. A line of best fit for the data is also shown for the neighborhood that had surveys sent to 800 people. So number of surveys sent to 800 people. So this is what I'm looking at. Which of the following is closest to the positive difference between the actual number of surveys returned, which is this 600, and the number predicted by the line of best fit, which is this point. So this is very similar to the previous question. So I'll take this as 460 maybe. Yeah, 460. So what is the difference between 600 and 460? That's 140, right? So from the options, the closest answer is 150, option A. Okay. This is a parabolic scatterplot. It shows the average fuel economy for a certain class of cars driven at 12 different speeds. The graph of the model is shown. For what fraction of the 12 speeds does the model overestimate the average fuel economy? Overestimate is to say that the model predicts a value which is greater than the actual value, right? Which means that the model is above the actual value. So start with this point. This point, the model is below, so this can't be considered. This can't be considered, not this, not this. For this point, the model is above. The model has overestimated, so this has to be considered. Not this, this has to be considered. Not this, not this, not this, not this, and this has to be considered. So for 3 points out of the 12, the model has overestimated. It has estimated a value higher than the actual value. So the fraction is 3 by 12, which is 1 by 4. So those are the kind of questions that you would see from scatterplots on the SAT math sections. You would have algebraic questions where you might have to find the equation of the line of best fit or the parabola that connects the dots. Or you could have arithmetic questions which ask you to interpret the data. Hope this was useful. If it was, hit like and subscribe to the channel. Let me know in the comment section what other videos you'd like me to make. I'll see you all in a new video soon. Take care. Bye-bye.